This is the second part of lesson 11.3, congruent triangles and their proofs. So using the things in the previous video, we've now got two new ways to prove triangles. So number one, it says prove whether or not the two triangles EFG and JIH are congruent using angle side. So again, I'm telling you to use this, so that's a hint that you're going to use it. When you do a two-column proof, you'll know, so on the left we have our statements and on the right we have our reasons. When you are trying to prove this is true, that will be your final statement. So in my final box down here, I'm going to be proving that EFG is either congruent or it's not congruent to triangle JIH. And I'm giving you a hint that the reason you're going to prove that is because of angle side. So I'm just going to leave that. I'm going to put a little question mark. So that's what I'm trying to find out if it's true. Again, in a two-column proof, the very first thing you want to do, generally speaking, is to state your givens. And so the reason that I know what the measure of angle E is, if you come and look, is because it was given to me in the picture. So I'm going to say 31 degrees because it was given. The measure of angle F is 105, the measure of angle I is 105, and the measure of angle H is 44. And all of those things were given in the picture, and so that's the reason that I know them. Now the next part of it, it says the measure of angle G is equal to what? So how can I figure out G? What is J? How do I figure those things out? And so if you think about what we know that since the angles in a triangle add to be 180, I can say 180 subtract 105 and subtract 31, and whatever's left is what's going to be left for that other angle. So I do the math there and I get 44 degrees. So that means that this angle is going to have to be 44 degrees. So the measure of angle G is going to be 44. Now over here, the question is, well, what do I put there? How did you know that that was going to be 44? So you had to do some calculations, but how did you know how to set it up? And if you think back to what we were just saying with that, is you know that the sum of the angles in a triangle are equal to 180. So there's a lot of abbreviation there. This is one place where abbreviating is fine as long as it's very, very clear what you mean. Okay, and that's the reason I know that. And so exactly the same reason, and that's why I've grouped these two together, that's exactly the same reason why you're going to find out what J is. So with J, you're going to say 180 subtract 44 subtract 105. And when you do those, that subtraction, you're going to actually get the same thing that you just had, or the other angle that is in the other triangle, so that's 31. So I know that that's 31 degrees. So where I'm setting up the proof for you, and I've done a lot of the skeleton of the organization for you, I've kind of grouped things together to make it easier. When you get a little bit more advanced, and we'll see some of this in secondary too, and then maybe beyond that, but you start getting so that this isn't set up for you at all. You get the picture and you get the givens, and that's all you have, and you have to figure out what's going to come next. And so I'm going to kind of start you with a lot of hints, but then we'll kind of let you be a little bit more independent. The next one, it says EG is equal to. So what is the length of EG? Or sorry, that's FG. EG. Okay, well, that's right there in the picture. I don't have to work for that at all, do I? So that's 10.3, and HJ is the same thing, 10.3. Okay, so how did you know that? Actually, that's a given also. That was also given to me. So sometimes you can put all your givens in one, and that would have been okay if I would have lumped them all in the same thing. But I actually just put it in a different one because it kind of came up differently. So, you know, it would be right if I had it all together or if I had it separate. It doesn't really matter. Okay, so the next thing, let me put that back in there. Okay, the next thing, it says angle E is congruent to what angle? So what angle is angle E congruent to? Well, it's congruent to the other one that also is 31 degrees, so it's congruent to angle J. Angle F is congruent to what angle? It's congruent to the other angle that has 105 degrees, so it's congruent to angle I. And EG, which is the side that's 10.3, is congruent to the other side that's 10.3, so that's going to be HJ. And so how do I know that? And so if you think back to what we just talked about on the previous video, congruent parts. And so I'm saying that these are congruent parts. It's because they have equal measures. So that's why I know that they're congruent, because they have equal measures. So I already found out up here that their measures were equal, and so because of that, I'm making the conclusion that they are congruent. And so if you look at what I have angle, and I have an angle, and I have a side. And so angle, angle, and then side. I should have done that the other order. Angle, angle, side. And then angle, angle, side. And so that's how I know that those two triangles are congruent. So I'm going to erase my question mark now. They are congruent, and it's because of angle, angle, side. Okay, number 2. Prove whether or not the two triangles are congruent using HL. Now, since it says HL, this is only good for a right triangle. So I'm going to first just check my picture. Do I have right triangles? I do have right triangles, so that is an option. If they weren't right triangles, HL is not an option, so I wouldn't even be asking you that. So since it's a right triangle, I know that Pythagorean theorem is something I could potentially use here. All right, that's just something to keep in mind. Let's go over here to our statement. So first I'm asking you a bunch of information. And so if you look at the picture, like KM, and if you look at the picture, like I can see from the picture that it's 72 and KL is 65. And so all of this information is just coming from the picture, and I'm not having to work for any of it. I don't have to solve anything or calculate anything. It's just all right there. And so what's the reason for that? And so we say that it's given, meaning it was given to me. Okay, so in your book right here, we see these two empty spaces right here. They're actually not supposed to be there. So if you have that in your book, if you want to just ignore them. Okay, so we're just going to go on to this right here, so ML. And so I'm looking for ML right there. And so how can I find that? So remembering that this is a right triangle, so I can use Pythagorean theorem to find that missing side. So I'm going to say 72 squared plus 65 squared. I know that's going to be a really big number. And that's going to come out to be 9409 equals x squared. Take the square root of both sides. It ends up being x is equal to 97. And so this side, the hypotenuse, is 97. So I'm going to write 97 right there. And so if I look at what I have here, I have that this hypotenuse and this hypotenuse are 97. So that means that ML is congruent to PO. And so that's actually my hypotenuse. So PO is congruent to ML, and so I'm going to put that right in there. Going back to this reason right here, how did I know that it was 97? I used Pythagorean theorem. And so you can just put Pythagorean theorem because that's how you found that out. All right, so I've got the hypotenuse, and so since I'm trying to use hypotenuse leg, I need to find out leg. And so if you look, I've got this leg and that leg. I've already said that they're both 72, so I can just say that NP is congruent to MK. And so what I have now is I have a hypotenuse and I have a leg. How do I know that they're congruent? It's, again, that congruent parts have equal measures. So congruent parts have equal measures. Okay, so then the last thing is, it says triangle blank is congruent to triangle blank. Well, if you're proving it, you're trying to prove what we told you to prove. So you're going to say triangle KLM is congruent to triangle NOP. Why? Because of hypotenuse leg. And so there's your proof. Okay, now number 3, it's taken up this whole page and there's a lot of information. And so let me just kind of walk you through what we've got. So first of all, given, this is all the things that you're given for this problem. Here's what you need to prove. And then what I'm doing is I'm giving you this 2-column proof with all these blanks in it, and you're going to get to choose from these things what's going to go where. Okay, so it's kind of like you're going to match the reason or the statement into the correct blank. So the first thing that we always should do with things like this is let's go to our picture and let's mark up the things that we know. So we know that ABC is an equilateral triangle. So I know that this side, this side, this side, they're all congruent to each other. So that's one thing that's helpful. Just by the way, in an equilateral triangle, it's also equiangular, which means each angle is 60 degrees. Now that may or may not come into play here. I'm just going to kind of keep that in the back of my mind in case that needs to come in, but just know that equiangular and equilateral will give you the same type of triangle. Okay, M is the midpoint of AC. What do you think the word midpoint means? So if we look at M being the midpoint of AC, that means that it's exactly in the middle. So that means that AM and MC are the same because that's what midpoint means. So it means the point and we call it equidistant. So the point equidistant from A and C. And so then it says N is the midpoint of AB. So if I look at N, it's the midpoint of AB. And so those two pieces are the same. And then P is the midpoint of BC. Now going back to the equilateral triangle thing, since I know that this piece is the same as this piece, that means if I split it in half, I'm looking at the exact same thing. So actually, even though I marked these with like a purple and a red and a green, I actually could mark them all with exactly the same marking because they're the same. And that comes from it being an equilateral triangle. So I'm going to keep that in the back of my mind too, that these are all actually the same. So what I have is I have this piece, this piece, this piece, this piece. All of those are all the same length, okay? It's really important when you're doing proofs also, don't jump to conclusions. So I'm not going to jump to the conclusion that this is the same as this one or this one. I'm not going to jump to any conclusions. You've got to be very careful because you're going to have to prove every single thing. Okay, now we're also told that AC is equal to 8. So this entire thing is equal to 8. So what does that mean about this piece? So think about that. Okay, what I'm trying to prove is I'm trying to prove that triangle CMP, so that's this triangle, is congruent to triangle BNP. So that's this triangle. So I'm trying to prove that, okay? And so looking at what I have to choose from, and there's more than one way you could prove this, and so to narrow it down, that's why I'm giving you these choices. So it's just going to all go the same way. And so what I've got is I've got all of these things that you can choose from. So let's take a look at what we've got. So first of all, I've got some givens. Okay, so I need to look in this group of, I don't know, 12 things. What are some of my given reasons? And so you've got 5 things that were given to you. So could you pick any of the 5? Yeah, you can. How do we know which one to do? Well, let's talk about what it says right here. This next one, it says N is the midpoint of AB. And if you look up here, that's the third one down, and that's the third one down. So I think I'm going to start this off with the equilateral triangle right there. So triangle ABC is an equilateral triangle because that was the first given. It's not that that necessarily has to come first, but it makes sense. Okay, so that's going to be one of them. So I'm going to cross these off as I go so that I know I've used it, so I'm not going to use it again. And then the next given was M is the midpoint of AC, and so that was another given. And then it says N is the midpoint of AB, so how do I know that? Well, because it was given, so I'm going to use given. And then I've got another place to put given, so what was the other given? The other given was that AC is 8 units. Oh, no, wait, I skipped one. The other given was the P is the midpoint of BC. It wouldn't be wrong if you did the AC equals 8 units, but we're just going in order, so that would make more sense. So P is the midpoint of CB. And so let me cross that off my list here. Okay, and then I'm going to say AC is equal to 8 units. So AC equals 8 units. And the reason for that is given. So I actually get to cross 2 things off my list here, that one and that one. So all I've done so far is list my givens, but I was able to cross a lot of things off the list here. You'll notice that some things are listed twice, and that's just because you're going to use them twice, okay? So then looking at what comes next, it says CB is equal to, now it says equal, not congruent, so I'm looking for an actual number. AB is equal to another number, okay? So let's go and look at CB. So CB, how long is that one? And then it's also asking about AB, so how long is that one? So since this one over here was 8, I know the other ones are 8. How do I know that? So I'm going to put 8 and 8. And so how did you know that they were 8? Look at your reasons up here. Which one of those would tell us that those other sides were 8? So if you look at this reason right here, sides of an equilateral triangle are congruent. That's how you knew that. So we're going to write that. Sides of an equilateral. And then for triangle, you can always just use the symbol triangle, R, and then for congruent, I'm fine if you want to use the congruent symbol. Then the next thing, it says MC equals, so I need a number. Okay, so a number. How big is MC? So coming back and looking at my picture, so MC, that's that one. So it's 4. So question, how do you know that it's 4? Well, because it's half of 8, right? And so look at my choices. Okay, so I've got definition midpoint. What was the definition midpoint? It says that the midpoint basically is the same distance away, so it's splitting that in half. So that seems like that would be good. Substitution, I'm not really substituting anything in here. Congruent parts have equal measures. I'm not saying anything about congruent parts in these statements. Nothing with congruence, so it's not going to be that one. And angle B is congruent. That's not anything we're talking about here. So it's going to have to be definition of midpoint. So that's what I'm going to use next. So definition of a midpoint, and the definition of midpoint is just saying that it's splitting it in two equal pieces. So 4, and they're all going to be 4. Okay, the next part of this, it says NB is equal to MC. So it's not saying they're congruent, it's saying that they're equal. And so if I look up at my options, it may not stand out to you what it is, but if you look back at what we just did, we were talking about MC right here, and we were talking about NB right there, and they were both equal to 4. So if I say that MC is equal to 4, which is also equal to BN, then that means that MC is equal to BN. And if you think about earlier when I talked about this, that's exactly what substitution says. So the reason for this is because substitution. We're not going to say congruent parts have equal measures here because we didn't say anything about congruence in any of those statements, and so we can't say congruent parts because we haven't talked about congruence. The next statement, we're saying something about congruence. So we're saying CP is congruent to what other piece? So if I look at CP, that's this one. It's congruent actually to a lot of different parts of this picture, but the one that's going to satisfy what I want to have happen the best is going to be that one. So I've already said that they're both equal to 4. Okay, we already said right here that they're equal to 4. And so that means that they must be congruent, because if they have equal parts, then they have equal measures. So I'm going to write congruent parts have equal measures. And I'm going to cross that off my list. Congruent parts have equal measures. Okay, and so then I'm going to come, over here. Oh, I forgot to cross off definition of midpoint. Do that. Okay, so I'm going to come down here, and then the next statement says NB is congruent to. Okay, so what do I want NB to be congruent to that's going to help me accomplish what I'm trying to accomplish? So NB is this one. I need it to be MC, so that would make sense. I'm going to say congruent parts have equal measures again because I've already said that they're the same, so they have equal measures right here. So I'm going to say MC, and that's going to be the same exact reason. So congruent parts have equal measures. Okay, and crossing that off my list of possibilities. Oh, I already did that. Okay, now the next thing, it says I've got to put something there, and it says angles in an equilateral triangle are congruent. So that means I'm trying to say that two angles are going to be congruent. So if I look at my reasons up there, or the things I have to choose from, angle B is congruent to angle C. That's the only thing that really makes sense. And if you look back at what the picture is, I said earlier that in an equilateral triangle, which is ABC, all of the angles are 60 degrees. And that would serve exactly what I want it to do, because that will help me show that this triangle is congruent to that triangle. So that's exactly what I want. So then the last thing, so now I've got this crossed off. So the last thing I need to do is just prove that the two triangles are congruent. And if you look at what I have, sorry, I've got so much written here. But if you look at what I have, I've shown that this is congruent to this, that's a side. I've shown this is congruent to this, that's another side. And I've shown that the angle in between is congruent. So I've got side, angle, side right there. So I'm ready to write my conclusion. So my conclusion is going to be that triangle CMP is congruent to triangle BNP, and the reason is because of side, angle, side. And so that is the proof. So this kind of proof where you have like lots of things to choose from, you want to really think out the strategy, and especially if you're going to need to use all of those pieces, think about like what's going to help me get to where I'm going. And it might be that you change your mind and you go back and say, no, that's going to fit there better, or something else is going to fit there better. So as you do these proofs, if you have things to choose from, you want to really think it out and just know that you can change your mind. You can go back and change your mind on something if everything's not fitting just right. Okay, you should now be able to do the assignment for 11.3.